Okay, perfect. So, good morning, everyone. You might have met me dancing salsa last night or yesterday on the stage. Apart from dancing salsa, I also play a pan flute. I went to Peru a few years ago, and I brought this pan flute from Peru. Let me play you something to set up the atmosphere for the cruise. So. We Angular is going on a cruise, going on a cruise, join us, going on a cruise. Angular is going on a cruise, going on a cruise, going on a cruise. So, hi. I'm Uri, Google developer expert for Angular, web technologies, whatever. I also love robotics and electronics, as you will shortly, really shortly see in this talk. Furthermore, I also blog a lot, so you can read about all my latest inventions in my blog. If you have your Bluetooth on your device and location open and you have an Android phone, you may receive a notification now with my personal blog link. It's called The Physical Web. You can read about it on my website. And last but not least, I work for BlackBerry. Yes, they still exist. So with that, what are we going to do today? So today we are going to do two things. First of all, we are going to explore two awesome web technologies. One of them is WebAudio. Anybody used WebAudio? Okay, so I'm going to show it to you. And then also Web Bluetooth. And then, the most important, we are going to have a lot of fun. I hope we are going to try to make some demos with hardware work. And that's always risky, especially when we are on a boat. So let's hope it goes well. So let's get started. So first of all, I want to tell you a little bit about one project that I've been working on like in 2009. It's called the Salsa Bit Machine. And the purpose of this project is basically to break down salsa music to individual instruments, just like we did yesterday if you attended my salsa class, in order to help dancers understand the structure of the music better. And it's also used by musicians as a practice tool if they want to practice their playing ability. And as you can see, I built it back then using Flash. Anybody here used Flash? Still using Flash? Nobody. Perfect. And I'm going to show you this tool real quick. It's like, it has a mixer-like interface where you can switch on and off any of the instruments and control the BPM, the speed, the rhythm of the music. And I'm going to do it using IE 11, because Flash is no longer working on my Chrome nor Firefox. So if you want to use my tool right now, you have to use i11. You can't use it on iPhones or Android. So back to 2009, this is my Salsa tool, and also a good opportunity to check out the audio output that we may have or may not have. Perhaps it doesn't even work on IE11, or is that the Wi-Fi? Let's give it, oh, it worked. Yeah, so you can see I can basically control each of the instruments individually. Just the guy that counts and the piano. Let's play something different. And then we can raise up the tempo. So this was like a real quick demo of what the tool can do. There is a lot more, and I would say that you can play with it, but you probably can't, because it uses Flash, it needs Flash. And I spent a lot of time working on this tool, and I know also there are many people using it and relying on it. And it's a shame you can't use it on modern browsers. So I decided to upgrade it a little. And now it's 2017, so we can do better than create Flash. So first of all, obviously, Angular plus TypeScript. Has anybody migrated from Flash to Angular? One guy. So you probably know, yeah. You probably know that TypeScript makes a lot of sense because Flash uses a language called ActionScript, which also has classes and types. So you almost copy-paste your code, and it works pretty well with TypeScript. So that was one good advantage of using TypeScript. And then other than Angular and TypeScript, the most important part of the Salsa Bit Machine is obviously the audio. So we have a WebAudio API, which is now supported on all modern browsers, even Safari. And it basically gives us the ability to generate this music on the fly. A few quick words about WebAudio. This is really cool thing, and you should check it out. We don't have, it would like take the entire talk to just speak about how awesome it is, so I'll just give you a few bullets. First of all, it lets us generate audio on the fly, just like we do on the Salsa Bit Machine. We can take samples, mix them together, or even create code that generates audio waves. Furthermore, we can record user audio from the mic and manipulate it, mix it with different sounds and presets, save it to the server, and do whatever we want with it. We can also analyze and visualize the audio, so we can build equalizers and spectrum analyzers and all the cool stuff that you know from your, if you have ever used audio editing system, sound editing system, or a DJ system. And you can also apply effects, even write custom effects in JavaScript, like reverb, bass boost, and whatever. So you can do pretty much everything you wanted to with audio using WebAudio. And I have to tell you, I implemented this Salsa Bit Machine also on iPhone and Android, and it was a pain. WebAudio makes it much simpler because you don't have to deal with raw audio data and mixing and algorithms if you don't want to. You can, but you have a lot of stuff already built into WebAudio. So I suggest that you just check it out, play around with it. And now let's move to the second part where we take this Salsa Bit Machine. And let me actually show you real quick what the 2017 version looks like with Angular and TypeScript. It's still a prototype, so I'm still working on the visuals, but basically this is the 2017 version that we are going to experiment with. And then as soon as I hit the play button, well, it basically does the same. So this is what our starting point is. We already have the user interface. We already have the WebAudio and the service that generates the music. And to make it more fun, we are actually going to, yeah, I just showed you that. We are going to make it connect to a robot and make that robot dance to the rhythm. So in addition to generating salsa music and like controlling it by controlling each of the individual instruments, we are also going to see it visualized using a small robot that dances. And for that, I want you to meet a small friend of mine. It's a 3D printed robot that I built. It's called Purple Eye. So this is Purple Eye. You can guess why. The only thing that is not purple here is the eye. And we are going to make this little guy dance. But we live in the browser. Like the Salsa Bit Machine app is a browser app. And we need some way to communicate with this robot. And as you might have guessed, we are going to use Bluetooth. And before we do that, I want to tell you a little bit about Bluetooth and how it works. So real short Bluetooth 101 introduction starting right now. Oh, first of all, if you remember for yesterday, dance is a function that takes music and returns movements. And yesterday we did it on the salsa class with our buddies, and today we are going to code this function for the robot. So we are going to do it using Bluetooth. And for that, a few words about Bluetooth. So Bluetooth 101. First of all, when you speak about Bluetooth, there are like two different kinds of Bluetooth. There is the classic Bluetooth that you use for your headsets in your car. And then there is a new standard called Bluetooth Low Energy or Bluetooth Smart, which is what we use today to communicate with most devices. And these are two different things. So if you have a Bluetooth device, but your code works with Bluetooth Low Energy, you can't connect to it, and vice versa. So today we are going to just focus about the newer Bluetooth Low Energy standard. And basically, if you have a device that supports Bluetooth 4 or a newer version, then it supports Bluetooth Low Energy. So any Bluetooth 4 device is relevant for us. And then, when we speak about Bluetooth Low Energy, there are some interesting properties. So first of all, you see this small battery. It can run off that battery for about a year. So it's really useful for devices in inaccessible locations. Like, imagine if you have a pacemaker. You don't want to replace the batteries every 6 weeks, right? So it finally allows us to deploy devices in locations where we can't change the batteries very often. In addition to that, it also has low bandwidth, so you have some trade-off. It uses low energy, so you can't send a lot of data, like 2 to 3 kilobytes per second. That's more or less the maximum. On the flip side, you get low latency. So from the moment that you send the data until it arrives at the other end, it's like less than 10 milliseconds. So it's very useful for sensors, for any kind of smart devices that you want to control remotely. And as you can probably imagine, this is not really useful for video or audio because the bandwidth is too small. Usually for connecting sensors or making robots dance, as we are going to do shortly. And finally, the most important part for us as web developers is that Web Bluetooth is here. It's a web API that allows us to speak with Bluetooth Low Energy devices directly from Chrome browser, as we are going to do right now. It's supported on Android, on OS X, on Linux partially. On Windows, there is a polyfill that I worked, so if you have Windows 10, you can install that polyfill and use it as well. The only platform that is not really supported yet is iOS, but guess what? There is an app for that. So even on iOS, you can download some app and get it working inside the app. So finally, we as web developers can leverage our skills to build web apps that communicate with real-world devices. And in order to do that, I want to take you through a quick journey where we'll see two very important things that we need to understand in order to speak Bluetooth Low Energy. So the first thing, you probably recognize the name. Oh, first of all, whenever you see the word GATT, just remember, GATT is another name for Bluetooth Low Energy. So GATT equals Bluetooth Low Energy. That's all you need to remember about it. And then the first thing you want to know about Bluetooth, and you probably recognize that from Angular, is services. So each Bluetooth device provides services, just like we have services in our Angular app that provide certain related functions. Same goes for Bluetooth devices. They have those services. For example, if we have a smartwatch, it may have a battery level service. which allows us to read the amount of battery left in our smartwatch. It may have environmental sensing service, which let us sense the temperature and humidity. And it may have heart rate service, which let us read the heart rate of the user wearing that smartwatch. So essentially, a service is just one block of functionality that a device provides. And there are many standard services like the ones on those lists. So if you build an app that can interact with heart rate service, it can interact with every Bluetooth Low Energy device that has that service, regardless of the brand and the specific device type. So standards are good, and this is one place where BLE shines. You build one app, and it can control a range of devices from all different manufacturers, at least in an ideal world. So a service is one function provided by the device. And then we also have the second thing we need to know about Bluetooth, which is characteristics. So characteristics are just variables that are exposed by the services. So we have a service like the heart rate service, and then we have variables that are available for us to read from and write to. So as variables, you can read from or write to them, and you can also observe them. So you can observe the heart rate of the user and get notification whenever there is a new value, because the heart rate monitor takes a reading once per second or so. So services are like a block. Each service is a block that provides one function, and then characteristics are how we interact with the services, read and write data to them. We'll summarize this with the most important slide here, which is this one. It shows the hierarchy of Bluetooth Low Energy. We have some device. It has one or more services, which are just different functions of the device. And then we can interact with them by using the characteristics, reading and writing from them. In this example, we only read from the characteristics. We have the battery level, which we can read to get the battery level, heart rate, and etc. So we had device, services, and characteristics. So remember this image, because now we are going to talk about how we use Bluetooth. And this is a pattern that repeats every time you want to connect or interact with a Bluetooth Low Energy device. Follow that. First of all, you scan for the device. So you just scan and let the user choose which device he wants to connect to. Once you found the relevant device, you definitely need to connect with it so you can interact with it. And then, going back to the previous slide, you need to fetch the service from the device, the service that you want to work it with. So once we connect to the dancing robot, we want to get the service that allows us to control the motors of the robot. And once we have the service in hand, we want to interact with it. So we get a characteristic, and this allows us to write and read from that service to the specific characteristic. So we get a device, connect to it, get a service, get the characteristics, and once we have the characteristic in hand, we can read from it, we can write to it, and we can, of course, RxJS it. So that was the basics of Web Bluetooth, and what I want you to take from here is that you basically don't need to remember all the code to do that. It's like 8 to 10 lines of code that we are going to see, but you can copy it from Stack Overflow. You just need to remember the ideas of device, service, characteristic, and follow them whenever you want to interact with some Bluetooth device. So with that, I think it's a good time for making the robot dance. First of all, I will need maybe some chair to put the robot on, so you can all see it. I need to come up with a robot to help me with carrying chairs. Are we good with the camera? So I don't know how good the robot will actually be dancing on a soft surface like a chair. We'll try that. But first of all, before the robot can dance, we need to write some code. So I'm going to switch to code. And we have here the code for the Salsa Bit Machine version 5, the one that you have seen, this one, you can notice here those red dots that indicate the rhythm. So you can see the red dot moving along with the rhythm of the music. And then what we are going to do, we are basically going to attach our own component just next to the red dot that will allow us to connect with the robot. So first thing, we are going to generate this component. We'll call it robot connector. It will take a few seconds. And now we got this robot connector component. We are going to add it to our controller just next to this beat indicator. Robot connector, save, reload, and see if it worked. No such files. I think I need to restart Webpack because I removed some files. Thank you, Webpack. So while doing that, it's a good opportunity to tweet my slides. So if you want to get my slides, you can find them on my Twitter at @urishaked. So tweet done, back to code. What's up with Webpack? Still running. So how many of you have spent a lot of time waiting for Webpack? OK, many of you. So a quick recommendation, some project to keep an eye on called Fusebox, which is like Webpack, but is faster, at least from my experiments. It's still a little difficult to set it up with Angular, but definitely keep an eye on this one. Maybe I will use it for the next talk. Having said that, Webpack is great. And now, let's see if I finally get this to work. Yes, Robot Connector works. So now that we got the component wired into the app, let's start adding some logic into it. So first thing we are going to do, we are going to add a small button that will let us connect with the robot. Button, MD button, and when we click it, we want to call the connect robot function. And then we'll also use nice Bluetooth icon with material design icon Bluetooth. And we'll also indicate that this button connects with the robot. And now the next thing we are going to do, we are going to sort of create a stub for the connect robot function. So this is the controller that was generated by the generous ngCLI. And we are going to add this connect robot method. Let's start with just console logging it works. So we see it actually works. And it's loaded, and yeah, it works. We created a button, and it works. That was Angular CLI Material Design 101. And now, before we get to the actual fun of connecting to the robot, one more step. We want the robot to listen for the rhythm to the beat events generated by the engine of the Salsa Bit Machine. So we are going to inject this engine service, which provides us the rhythm. And then whenever we have this connect robot method, we are actually going to subscribe to the bit. And we are going to do a few things with this bit. First of all, the bit comes every few milliseconds as a floating point number that is increasing whenever there is a bit in the music. So if we just printed the raw output, we would get a lot of floating point values, like let's do it now and play. So perhaps the font is a little small, but you can see 7.2, 7.256, not something that is convenient to work with. So we are going to do a few things. First of all, we are going to use math.floor to turn this bit into an integer. We are also going to use the remainder of dividing by 8. So we get a loop every 8 bits. So it goes back to 0 whenever we get to 8. And we are going to add 1. So instead of 0 to 7, it will be bits number 1 to 8. So eventually, after adding this map, we will get numbers from 1 to 8 indicating the current bit. So let's demo that. And you can probably see we are getting each number multiple times. And in order to fix that, we are going to use a nice operator. Thank you, Ben Lesh, for implementing it. It's called distinct until changed, which will make sure that we get each number once. We don't get repeating values in the stream. We'll save. What did I do here? We will reload. Go away.
Oscar, 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 starboard side. Oscar, 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 starboard side. Oscar, 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 starboard side. This is a drill for the crew only.
Thank you. We should also synchronize that with the rhythm. Oscar, 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 go outside. Okay, yeah, so let's see if it worked. Okay, yeah, so now we get each number once. So I think with that, we are ready to connect to our robot. Let's write a code for that. So first of all, this I already created a small service called Purple Eye, just as the robot, that will interact with the robot, so we don't have to live code all of that. I'm going to take a look at that service right now. It's something real basic. And as we open it, you can see this is the Web Bluetooth API, just a few lines of code. Basically, I scan for device, so I use this navigator.bluetooth.request device to scan for device. Do you remember we had the 5 steps we had to do in order to interact with Bluetooth devices? So this is the first one, scanning for devices. And I'm telling the browser, hey, I want to get all the devices with this service. This is just the number of the service that this robot provides for controlling the motors. Then I connect with the device here. Then I get the service. Then I get the characteristic. And finally, I save it to a class member. And once I got the connected to the device, got the service, got the characteristic, I can finally interact with it by writing values into it. So we have another method called move that basically takes 4 numbers, which are the motor positions in angles, and it simply writes them to the characteristic. So this is the 5th step after we have scanned for the device, connected to it, got a service, got a characteristic. We are interacting with it in the move function. And once we have this abstracted as a service, we can actually use it from our controller. So we are going to call this .purpleeye.connect to connect with the robot. Let's make it async, so we actually wait for this. And then once we are connected with the robot, we can actually translate those bits into robot movements. And in order to do that, I'm actually going to do a nice trick with hot reloading. So I'm going to create a new file called moves.ts, and this file will expose the most important function, which is the dance function. It will take the bit number and map it to motor positions for the robot. So this is the dance function. As you can see, it simply takes the bit, which is a number between 1 and 8, and return 4 motor positions for each of the robot legs. Robot motors. And then I'm going to use this function. So I'm going to import it, import dance from moves. And I'm going to just place it on my constructor, dance function equals dance. You'll see in a moment why I want to save it on my constructor. And finally, I want to say this. Let's call it moves equals this.dance fn bit. So this is the dance function, takes the bits and returns the movement to be sent down to the robot. And then we call this.purpleeye.move. And we can give it the 4 numbers that we got from this function, which are basically the motor positions. So dance 1, dance 2, dance 3. Okay, perfect. And it's not happy because, yeah, I know it returns a number. It's okay. Still not happy. Oh, maybe it takes. All right, it was moves, not dance. Thank you, Typescript. Moves, right. Thank you, audience. So Typescript and audience are my biggest savers today. Okay, so basically we got it all wired. We are connecting with the robots, and then after we are connected to it, as we have seen, we are mapping the bits into moves that are sent using Bluetooth down to the robot. One more thing we want to add. So once we start the Salsa Bit Machine and connect to the robot, we probably want to experiment with different moves. And we don't want to have the page reloaded each time because it will disconnect us from the robot and we'll need to connect again. So in order to fix that, I'm actually going to use a neat feature in Webpack called hot reloading. So basically, if anyone here used hot reloading in Webpack? Just Justin. So yeah, it's really awesome features. Like I can just tell it, you know what, Webpack, whenever this file is changed, instead of reloading the page, I want you to print this message and then just get me the new code from the same file name, moves.ts, and then I can patch the dance function. So instead of having to refresh whenever I change the dance function, I can simply change the dance function at any time, and it would update my application without reloading the page. So I can keep the connection to the robot. So that's all the code it takes to add robot connectivity to this amazing Salsa Bit Machine. And I want you to actually be able to watch it. So what I'm going to do, I'm going to try to set up a small webcam on the robot so you can see it crashes as soon as it realizes it's on a couch and not on a flat surface and on a boat. So my webcam is ready. And let's save. Let's go to the move function. Oh. Moves. It didn't load the font correctly, so we got the word Bluetooth instead of the icon. Now it works. Okay. One camera here. Okay, so one little robot, hopefully dancing in a moment. So this is the prime time, trying to see if we can get this little guy to dance. So first of all, we are going to play the music. And now, we are going to click the robot button, hopefully connecting with the robot. So now we are scanning for the robot. Hopefully we'll find it in a moment. If not, okay, we found something. That's the Bluetooth address of the robot. Usually it displays the name, but this time it doesn't want for some reason. So we'll go with that. And now we are pairing with the robot. This will take about a moment or two, and it starts moving, trying to keep up with the rhythm. And let's make it go faster. I think it's a little shy. It's like moving away from the camera all the time. Okay, let's go a little slower and do something fun. So we set up the stage for live reloading, hot reloading, and now we can start to modify the dance function. Let's try this shimmy function instead. So we are going to replace the dance function with a new one, and hopefully in a moment you will see the robot doing some new stuff. Go faster, my friend. Yeah, spread the legs, open, close. Yeah, please bring the bed table. That would work even better. Thank you. You are very reactive today. Yes, and now you can see yourself in the background. You know what? Let's put some merengue music for this robot. Let's switch to another function. I have another function that I created for merengue. Hey. Merengue. That was moves. Okay, save. We don't need to reload, we can just play. And now let's switch to merengue music. So it's no longer shy, now it's actually dancing in front of you, facing you, the audience. Let's make it dance fast. Don't show us your back. And as soon as we click stop, the robot stopped. So Tracy, how much time left do we have? Out of time. Okay, so perfect. So to summarize, just in time, out of time. So to summarize, first of all, what I want you to take away from here is that like Angular and the web are simply awesome. They finally let us do things that we couldn't imagine having done even 3 or 4 years ago. We can connect with this robot and other fast, exciting devices, like all those EEG headsets that we have seen in Alex talk yesterday, smart bulbs and whatever. You can find a few examples on my homepage. And now for the fun thing. Since it's NG Cruise, I'm going to hang around with you with the robot. Christian also, not Christian, Sebastian Christian also got a cool robot, and we are going to play with it. And during the hack night, I'm actually going to take this Salsa Bit Machine and connect it to Sebastian's robot, also smart light bulbs, and make it really cool. So this is just the beginning. We are going to have a lot of fun hacking with Web Bluetooth, WebAudio, whatever you want. Come to me, and remember, this is the future, so let's help building it.